Today, we're going to go ahead and create a sci-fi customizable procedural DNA strand. We're going to make it such that at any point of time, you can go ahead and change the length of the DNA strand, the number of twists in the DNA strand, and even the number of connections in between the double helix structure. We'll have a few more controls as well, and we're going to learn how to create the entire thing within geometry nodes. We have created SciFi DNA tutorials before, and you can watch maybe one of the videos over here, but that wasn't as customizable as today's is going to be. We're also going to learn how you can texture this as well as compositing to make this final animation. We're going to make it very beginner friendly and we're going to go step by step, so let's go ahead and actually begin the tutorial. In our default scene, we're going to bring our cursor to the junction of these two windows, click and drag to create a new window, and then switch this from the 3D viewport to the geometry node editor over here. Then we'll press this plus button to create a new geometry node tree, after which we can go ahead and just zoom in and remove the connection between the input and the output. That's because we don't actually want to use the input geometry because we'll be creating the entire geometry within this geometry node section itself. Now, the main idea is to create a curve line that's going to go up in the z direction, but we're going to move it away from the center, and then we're going to wrap it around the center to create one side of this double helix. Then we're going to repeat that entire process, but we're going to move the original curve line in the opposite direction, which will create the double helix. Then we're going to create the connections between them to form the entire DNA structure. Hopefully that made sense, but we're going to get a clear idea of exactly what's happening when we start building, so let's start building. The first thing is pressing Shift A and searching for a curved line. Now we're going to take the curve output and plug that into the group output. Now you see we are able to get the curved line, but we want to control how long it's going to be. You can do that by changing this z value, but we want to make this very customizable. Hence, we want to be able to just change this using a single value from the modifier panel right over here. In order to do that, we can use another group input. But you see, we just want to control the z value. We don't want an entire vector where we get control over the x, y, and z. So what we do is press Shift A and search for a combine xyz node, so that we get access to just the z value instead of having to control the x, y, and z together. Let's plug this in over there and take this z and plug that as another input to the group input. Now you'll see that over here in the group tab, you'll be able to see another input over here. Remember, if you're not able to see the side panel, you can tap N to just bring it out. Now we're going to go ahead and rename this from z to something like height or length. You can change it to whatever you think will suit your needs, but I'll just keep it at height for now. You can choose a default value as well as a min and max. I'm going to change the min to 0. And for the default value, we can say that at any point of time when it's created by default, it'll have maybe a value of 5. Now let's go ahead and just increase the height in our geometry node slider over here. And for now, maybe we'll start the tutorial with a height of 5 itself. Now we have this particular curve line that's going up in the z direction. But as I stated, we need to get this to actually move away from the center so that we can wrap it around the center. Let's see how we can move it away from the center. That's actually very simple. All we do is press Shift A and search for a set position node. Now when we plug that in, we want to offset it on maybe the x-axis by some amount. Now that amount will determine how fat our DNA is going to be. So in order to have control over that, we can use another group input. Again, we want just the x-axis. So let's duplicate this combine xyz node by clicking it and then pressing Shift D and then taking this x and plugging that as another input. We're going to rename this to maybe width, and now we can plug this into the offset. So just like before, we'll have the default set to maybe something like 1. We'll keep the minimum at 0, and now let's just go ahead and move this to a value of 1 for the time being. Now you see it has moved away from the center. Remember, the center is 0, 0, 0. We want to now rotate this or wrap this around that center. So in order to do that, we can use another set position node, but you see the curve line has only 2 points, one at the bottom and one at the top. To get this to nicely curve around the center, we need many more points, because only then can we change this from a straight line to a curved line. So to create many more points, we can search for a resample curve node. So press Shift A, search for resample curve, and plug that in. Now this count can also be a group input, but I'll just leave that at something like 1000 for now, which should be enough at any point of time. Next, we're going to go ahead and start wrapping this. To wrap it, we're going to use another set position node. So let's select it, press Shift D, bring it over here. Now we're going to just change the offset back to 0 because we're going to be playing around with the position. Now, firstly, if you search for a position attribute, so let's press Shift A and search for position, you'll see this particular position is going to be a vector that goes from the origin to whatever point you want. So this would be a position vector. Now for this point, the position vector would be something like this. Remember, of course, these are all going to be straight lines. Mine are just curvy because I'm using my mouse, but that is what the position vector looks like. This particular vector can be rotated about the z-axis based on its height, and that should become the new vector. So right now you see these position vectors. If we were to take this position vector and just rotate it about the z, it'll rotate in that direction just like that, and we can take the point that was over here and just place that over there. So hopefully that would make sense. And the higher you go, so this vector would have to rotate even more and would maybe rotate all the way to there. So as we go higher, it should rotate more and more. Hopefully that made sense. Let's go ahead and actually do that. So let's take the position, and to rotate this, press Shift A, search for a vector rotate node. Now take the position as the original vector. The center is going to be 0, 0, 0, and remember, we're rotating it about the z-axis, so the axis is going to be this itself, which is the z-axis. The angle is going to be based on the z position of each point. So let's separate out the z position by pressing Shift A, search for a separate xyz node, plug the position into the vector, take this z, and we are going to plug it into the angle. However, we don't want to directly plug it into the angle. Let's first see what happens if we plug it directly, and then we'll make the change accordingly. So once it's plugged into the angle, take this vector, and we want to take the position that it currently is and completely ignore it and put it in this new rotated position. So we're not going to use an offset, but we're going to use the position input. So let's take this vector and plug that into the position input. So now you see you're able to get a spiral. However, we now no longer have control over how much of a twist we want. If I wanted to twist even more, we cannot do that anymore. So that's why instead of just taking the z and plugging that into the angle, we're going to press Shift A, search for a map range node, plug that in right over here, and you see the from min is going to be 0, but the from max is going to be the height of the actual curve. So the height is coming from this group input. So we can actually just take this, plug that into the from max. Now for the 2min and 2max, we essentially want it to be a number of rotations that can be controlled from the output. So to do that, let's go ahead and take another input and plug that into a math node. So let's press Shift A, search for a math node, switch this from add to maybe multiply, and take this new input from the group input and plug that into maybe the first value of the multiply node. The second value we can type in 2 star pi, which is essentially one single rotation. So if the input is going to be 1, this is going to rotate 1 full time. If it's going to be 2, it's going to rotate 2 full times. So once we take this, we can plug that into the 2 max, and now again we can have a default value of maybe 1 itself and play around with the value from this slider over here. So you see, if we have a value of 1, it's going to have exactly 1 full rotation. We can see that by pressing 7 to go into the top view, it does 1 full rotation. That is exactly what we want. If we have a value of maybe, let's say 0.5, it should do half a rotation. So let's press 7 to go into the top view, and you can see it does half a rotation. So we're going to call this as number of twists, or we can just say twists, and that should be good enough. Now let's keep it at a value of 1 for now, while we go ahead and duplicate this entire section for the other side as well. So that's actually going to be very simple to do. Let's just shift this group output over to the side, press Shift A, search for a join geometry, plug that in right over here, and then just duplicate all of these nodes by just selecting them and then pressing Shift or Control Shift D if you have the node wrangler, so that all the connections remain connected. Now all we have to do is move this in the other direction. So before this goes into the X, we want it to move in the negative X. So we can take a math node by pressing Shift A, searching for math and plugging that in over here. And instead of adding, we're going to multiply by a value of -1. This will move it in the opposite direction, And now we can go ahead and take this output and plug that into the join geometry. The moment we do that, we get our double helix structure, which is exactly what we wanted. And that's all there is to creating a double helix. Now this is completely procedural. You can see we can go ahead and just increase the width if we want. We can reduce the width if we want. We can increase the number of twists. We can reduce the number of twists, as well as play around with the total height of this DNA strand. So that is what makes this very, very customizable. However, there's still one thing missing, which are the lines that connect the double helix structure. So to make those connections, we're going to simply create another curve line that goes from this end to that end and use that as an instance on various points that go up all the way through the length of the DNA. So in order to do that, let's go ahead and first create that line that goes from this end to the other. So let's press Shift A, search for a curve line. And remember, the curve line has to go from the width on the negative x-axis to the width on the positive x-axis. So we're going to have to play around with just the x-axis values. So let's press Shift A, search for a combine XYZ node, and now plug this in so that we get access to just the x. So let's go ahead and now take the width input and plug that into the x value of the combine XYZ. Now, if we were to just take this curve line and plug that into the join geometry, you should be able to see that we get a curve line, but it's going up on the z-axis because we have the end at a value of 0, 0, 1 by default. We don't want that, so let's just change this to 0. And now you see we have something that's going in the x-axis exactly to where the double helix structure starts. But we want this end value to be all the way over here. So we can go ahead and just Control Shift D this combine XYZ and plug this into the end. However, now it's starting and ending right over there, but we want it to go in the opposite direction. Remember, to make it move in the opposite direction, all we need to do is multiply by -1. So press Shift A, search for a math node, change this from add to multiply, and multiply by a value of -1. And now you have a line that goes from this end all the way to this end. Now we don't actually want this to go into the join geometry, so let's just remove that connection. Instead, we're going to search for a curve line that goes from the bottom to the top. That's very simple to do. All we do is duplicate this curve line by pressing Shift D. And of course, instead of duplicating just the curve line, we could have taken this combine XYZ as well, because that is already connected to the height input. Let's press Control Shift D. And now we have a curve line that's going to go all the way to the height of the DNA if we plug this into the join geometry. So let's plug that in. And now you have that line. Now on this line, we can go ahead and make as many points as we want, which is going to be another input from the group input. So let's press Shift A, search for a resample curve node, plug that in right over here, and the count is going to be an input from the group input. So let's just plug that in. And if you feel like there's way too many connections going all the way over there, you can always press Shift A and search for another group input right over here, so that it doesn't have to come all the way from there. We can just take the count from here and plug that in to the resample curve over here. Now that we have this, remember the count has a default of 10, minimum of 1, maximum of whatever. I think that's perfectly all right. We will call this maybe connections instead of count, just so that it's easier for us to understand what it is. Now that we have that resampled, it means this curve is now made up of how many ever connections we make over here. So if there are 10, there will be 10 points present on this curve. If we were to increase this to 20, there are now 20 points on this curve. So on each of these points, we want to instance this curve that we just created. So let's press Shift A, search for an instance on points node, and plug that in after the resample curve. Now for the instance, we're going to take this curve line and plug that in just over there. So we have that many lines. Let's reduce the number of connections to something like 10 so that it's easier to see, but we still have a problem. All of these lines are present just like that. We need them to rotate based on how the double helix is rotating as well. So that's actually very simple to do because we have a rotation input for the instance on points. So again, remember we need to rotate this about just the z-axis. So we're going to have to search for a combine XYZ so that we get access to just the z. Let's plug that in over here. And for this z, remember we actually get the rotation from this map range output, because this result is going from 0 to the height and it's rotating it based on the height, which is exactly what rotation we want for the instances. So let's take this result, plug that into the Z socket of the combine XYZ, and immediately you should have a perfectly working DNA structure. So that is actually all there is to creating this DNA structure. Now, just to show how customizable this is, we can increase the number of connections as well, and you could use this for many other sorts of animations as well. Just by increasing the number of connections, you get this really cool wave-like effect. So you could make this into another wave animation as well if you feel like that is what you want to do. However, right now I want to make a DNA, so I'm going to reduce the connections down to 10 and leave it just like this. The next part is actually getting all of those spheres to be instanced onto these lines. In order to do that, we're going to actually use a small little hack, which is we're going to convert this from curves to a mesh and then distribute points on the mesh. So let's press Shift A, search for a curve to mesh node, and for the profile curve, we're going to use a curve circle. So press Shift A, search for a curve circle, and plug that into the profile curve. Now, a resolution of 32 is way too much, and a radius of 1 is also way too much. So let's reduce the radius down to 0.01, and we're going to reduce the resolution down to 3. So this is going to be very fast for your computer to calculate, and the faces are also being created. The next step is to distribute a bunch of points onto these faces. So let's press Shift A, search for a distribute points on faces node, and plug that in after the curve to mesh. Now we're just going to increase the density to something really high. Let's go with something like 10,000, and that should be good enough. Remember, at lower values, you'll actually be able to see that there are quite a few more points present along this curve rather than the actual interconnections between them. And in order to fix that, we can press Shift A and search for a realize instances node and plug that in after the instance on points. So that way, everything just becomes more uniform, and we can now go ahead and just increase the density all the way to 10,000 so that we get what we want. But this is obviously just way too uniform. We need to get some randomness involved. So in order to do that, we're going to search for a set position node, plug that in right over here, and we're going to play around with this offset. The offset is going to be generated by a random value. So let's press Shift A, search for a random value, and we're going to change this from float to vector because we want to move it randomly on all the 3 directions. Now we want the min and max to be given as an input from the group input. So let's go ahead and just take this group input, press Shift D to duplicate it, bring it over here, and create a new input. Again, since I always want all 3 of the values to be a single value, we don't need to just plug this in directly because that's going to create a vector and you'll get 3 different values to control. We don't want that, so press Ctrl Z and press Shift A, search for a math node, and with this math node, we can go ahead and actually control a single input from the group input. Now the reason why I'm using this math node is because remember the min has to be the negative of the max. So instead of add, we're going to make it multiply, and we're going to multiply by a value of -1, and that is what's going to go into the min of the random value. The max is going to come from the value itself, so let's just plug that in, and let's rename this from value to maybe randomness, and now we can plug this value into the offset. Now it's way too high, and that's because the randomness default is very high. Let's change that to maybe a default of 0.05, and now we can reduce the slider down as well to maybe 0.05. Now that looks good enough, but there's a lot more that we want to do. The first thing is it's still too uniform. I want a few particles to be completely out of the structure. So in order to get a few particles completely out of the structure, what we do is we just move this to the side, select this set position, press Shift D and duplicate it. Now we'll press Shift A and search for a vector math node. And again, if you want to know exactly how to use the vector math node, you can check out this video over here where we go into a deep dive for the basics of the vector math. But for now, we're going to change this from add to scale, and we're going to take this output and plug that into the input. Next, we're going to scale it up by a large number, maybe something like 3, and then plug the vector into the offset. But I don't want it to happen for everything. So to get a random selection, we're going to press Shift A, search for a random value node, and we're going to change this from float to boolean, and we're going to reduce the probability to something really low. Let's start with 0.1, and we can change the seed to a random number, and now plug this value into the selection of the set position. So that way, only a few particles will get this random position that's been scaled up by 3 units. You can always increase how much you want to move it, or you can reduce the number, but I think a scale of 3 is good enough for what I want to do at the moment. Right now, it still doesn't look great, and that's because the points are way too large. Maybe I'm going to go ahead and just reduce the density from this high number to maybe something like 5,000, so it becomes half as dense. And then I'm going to go ahead and instance onto these points some spheres. I also think that the density could be an input, so let's just plug this density into another input of the group input node. We'll leave it at density itself. We'll keep the default value for the density at 5,000 as well. Now let's go ahead and press Shift A and search for an instance on points node. Let's plug that in after the set position, and for the instance, let's press Shift A and search for an icosphere. Let's plug that in right over there, and now you see it is way too large. So let's start off by reducing the radius to something like 0.01, and maybe this radius can also be an input. So let's duplicate this group input. Let's go ahead and plug this radius in right over there. Rename this from radius to maybe size or particle size. We'll keep the default at maybe 0.1, and we'll increase this to 0.1 as well. Or maybe I'll keep it at 0.05, or maybe even smaller. Let's go with 0.02. Maybe that should be the default as well. But once you're done with that, we actually want to randomize the scale. So in order to do that, we press Shift A, search for a random value node, and this time we're going to keep it at float, but we're going to change the min to maybe 0.2 and the max to maybe a value of 1.5. And now we can plug this into the scale, and they become random sizes, which makes this look a lot cooler. The next thing is making sure that this is much smoother. So to do that, we'll first increase the subdivisions to maybe 3, and then we'll press Shift A, search for a set shade smooth node, and we'll plug that in just after the icosphere before it goes in as an instance. Now that looks great, and I think I'm just going to leave it like this before I go into the actual shading. So for the shading, there's a few things that we need to do, which is setting the material in the geometry nodes section right over here, as well as capturing a random value for each of these instances. So in order to store an attribute for every single instance, let's press Shift A, search for a store named attribute node so that we can actually use this attribute in the shader editor. Let's plug that in right over here. And remember, we are storing a float, not for every point, but for every instance. The name is going to be random value. So let's say RNDV. And for the value, I'm going to use an actual random value. So let's select this, just press Shift D. You can press the backspace to reset it to go from 0 to 1, which is exactly what I want. And I'm going to choose a random seed and plug that into the value right over there. Once you have that selected, you can go ahead and press Shift A, search for a set material node, and plug that in right after the store named attribute. For the material, we'll just select it and choose the default material because we're not using that for anything else. Once you're done with that, let's go ahead and start with the actual shading. But as a continuation to the setup, let's go over to the render properties, switch on bloom and screen space reflections. Then let's go and switch our viewport shading to rendered as well. And for the world background, let's just decrease the brightness quite a bit and maybe make it a little bit bluish. So that should be good. Maybe you can select the light, and if you don't want the light, you could just remove it. I think that will be good enough. Now with this object selected, let's go ahead and switch from the geometry node editor to the shader editor and start playing around with the actual material. If you can't see the nodes, just tap A to select everything and period on your numpad to centralize the nodes. Now the first thing that I'm going to do is increase the metallic so that everything reflects off of the few that are going to be lit. The next thing is reducing the roughness down to something like 0.3, and for the base color, I want some of them to be dark and some of them to be bright. So let's press Shift A, search for a color ramp node, and we're going to plug this into the base color, but to actually control the randomness, we're going to use that attribute that we had stored. So let's press Shift A, search for an attribute node, and we're going to have to choose the correct name, which was RAND and followed by a V. But remember, we stored it for every instance. So we're going to have to change the type from geometry to instancer and plug that color into the factor. Now, if we were to just Control Shift click the color ramp with the node wrangler enabled, you can see how each circle or each sphere gets a different color. So we can go ahead and just crunch these in, and we're going to also change this black from a value of 0 to maybe a value of 0.1 so that it's never completely dark. Similarly, the white section can also be changed from a value of 1 to maybe a value of 0.5 8 so that it's never completely white either. Another thing that you could do to randomize this even more is pressing Shift A and searching for a white noise texture. If you just plug this white noise texture in over here, the color that we get is not going to be dependent on the other thing that we're going to do with this random value from the attribute. So in fact, we'll actually show you what happens without this white noise texture. So I'll mute it for now, and then I'll use it to show you what the difference is. So let's press Shift A, search for a layer weight node, and let's search for a color ramp node, or we can just duplicate this color ramp. So select it, Shift D to duplicate, and now we can take the facing and plug it into the factor, and let's just Control Shift click this to see what we have. Let's just press the backspace to reset the node, and I'm going to bring the black in quite a bit so that we just have that outer edge. Now I want this to act as a mask to the emission. So let's just expand this emission, plug this into the strength, but this will give us a max strength of a value of 1. So to go beyond that, let's press Shift A, search for a math node, plug that in, and change this from add to multiply. And now if we multiply it by a large number, we will get a lot of bloom and it'll be really bright. Let's keep the value at 10 and just Control Shift click the principled BSDF to see what we have as of now. We won't be able to see the outer rim because the color of emission is currently black. Let's just increase that value all the way to a white, and maybe we can give it a bluish color just like that, and this is what we have. Every single sphere is being lit up. I obviously don't want that, so what I'm now going to do is I'm going to press Shift A and then search for another math node, and this time I'm going to keep this not at add but at multiply, so that we can multiply this by another mask which is going to select only a few of these, so that only a few are actually going to have this edge ring. So to get a few of these, remember we already have a random value that's coming in from here. And in fact, we don't need to use the color, we could use the factor itself. There's no reason to use the color from the attribute. But remember, it's giving the same output itself. It's just a tiny bit faster to calculate when it's just using a factor and not converting a color into a factor. But we're going to duplicate this color ramp, and we're going to just reset it by pressing the backspace, and we're going to change this from linear to constant. Now we're going to bring this in and take this factor, plug it into the factor, and take this output and plug that into the multiply. Let's now plug this into the strength and Control Shift click the output of this multiply for now. Now you can see only a few of them are actually going to be lit up. You can control how many are lit up by playing around with this white slider. So if you want very few, you bring this all the way towards the end. If you want almost all of them to be lit, you move this all the way towards this end. But I'm going to keep it maybe somewhere around 75% should be off. So let's change this to 0.75, and that looks perfect in my opinion. Now if we Control Shift click the principled BSDF and we just go ahead and increase our background just so that we can see the actual dark and light shades, you'll notice that only the lighter shades are going to have the actual ring. None of the darker shades or the darker spheres are going to have the ring light, and that's because, remember, we're using the factor to determine which ones are dark and which ones are light, and we're using the exact same factor or the same random value to determine which ones are actually going to be lit. So it's only evident that the ones that are already the brightest over here are the ones that are going to be lit up over here. So in order to change that such that the light is independent of the color, we use this white noise texture. So let's unmute it, take the color and plug that into the factor. Now you'll see it's randomized. So we have some dark ones also emitting light and we have light ones also emitting light, and it becomes completely independent, which is exactly what I wanted. So now we can just take this background or the world background and reduce it a bit just like that. And now if we just switch off overlays, this is what we have, which I think looks really, really pretty. And now that we have this SciFi DNA, we can go ahead and start off with the animation before we complete the scene with the camera and compositing. So for the animation, it's going to be really simple. Let's first start off by going to the output properties, changing the resolution to 4K by changing the percentage slider to 200. Frame rate, I'm going to keep it at 60 frames per second. The end frame, I'm going to make it 300 so that it's just a 5-second long loop. Output folder can be wherever you want it to be. A double slash will save it wherever the blend file is saved, so remember to save your blend file. File format is going to be FFmpeg video, and the encoding, we're going to change the container from Matroska to MPEG-4 with an output quality of perceptually lossless. Then we're just going to go ahead and expand this timeline and press the back arrow to go to frame 0. If there are any other keyframes, just select them and tap X to delete the keyframes. Now with this cube selected, we're going to go over to the object properties over here, and for the rotation about the Z, we're just going to press this little dot to add in a single keyframe for this rotation. Then we're going to go all the way to frame 300, which is the last frame, and we're going to change this to 360 degrees, which means one full rotation, and then we're going to go ahead and now press this diamond to add in a keyframe. So if you were to just play the animation now, you'll see it starts off slow, it speeds up in the middle, and then even towards the end, it's going to slow down, which is not exactly what we want. We want it to move in a smooth loop. So to make it a smooth loop, we'll just go down here, tap T, and then choose linear. So now we have a smooth loop from start to end, and it'll be completely seamless. If you want to see the real speed at which it's rotating, change the playback from play every frame to frame dropping, and that way you'll get a realistic idea of how fast it's actually rotating. Now we're going to go ahead and add in the camera, then set up the scene, after which we'll do the compositing. So we already have a default camera in the scene, so we can just select it and press 0 to go into the camera view. Now you can just press this little button over here to lock the camera to the view so that you can navigate as you generally would navigate anywhere else in Blender. So I actually want to bring this a lot closer, so let's just zoom in, and I want to actually rotate this so that it's going diagonally in my view. So instead of rotating the object, I'm going to rotate the camera. So I'm just going to select the camera, press R followed by Z twice so that it's rotating about the local Z axis. So now I can just rotate it to whatever angle I want. Maybe let's go with something like this. And then I'm going to go over to the camera properties and play around with the focal length. So I'm going to reduce the focal length to maybe something all the way down to 18 so that we actually get a nice fisheye effect and it actually becomes a lot more 3D. Apart from that, I think I do need to make sure that this is a bit longer. So because this is procedural, it's very simple to do. We can just go to the modifiers, increase the height, and we'll just increase the number of twists to compensate as well as the number of connections. Then let's just select the camera and shift it up. And I think that looks great. Next, in my camera properties itself, I'll go to viewport display and increase passbar 2 all the way to 1 so that we don't see anything outside our camera view. Now this is what it currently looks like. We can make this look even better by going ahead and adding in some depth of field. Before you do that, once you're happy with the positioning of the camera, ensure that you just toggle this once again so that you can zoom in without actually moving the location of the camera. So to add in depth of field, you can just check this depth of field option, expand this, and just reduce the f-stop to something really low. Then for the focus on object, you can go ahead and use this eyedropper tool and just choose the default cube as the object, and now it'll be focused only on that object. If you're happy with this much of depth of field, you can keep it, or you can just start increasing the f-stop till you get the amount of motion blur that you find perfectly suitable for your scene. I'm going to leave mine at a value of 0.2. The next thing is creating some background elements. So let's select this and then press Shift D to duplicate it, and then press Shift D to duplicate it once again. Then I'm just going to select both of these by pressing Shift and Select. I can also switch on overlays just so that you can see it better. And then I want to move it back away from the camera. So to move it away from the camera, I'm going to change this from global to view, and now it's going to move only with respect to my view. So to move it away from me, I can press G followed by Z and it'll move away from me. So I can move it as far away as I want, but I'll just move it maybe that much for now. And then I'll just select this, press G and bring it over to the side so that the edges cannot be seen. And I'll do the same for this one as well. The next thing is I want these two to be rotating in the opposite direction as the main one. So with this one selected, I can go over to the object properties, go to frame 300, and instead of plus 360, I can make this minus 360, and then just double click this diamond button to add in a new keyframe for the new value. Same thing I'm going to do for this particular DNA. So select this, make it minus 360, and then just double click this, and we should be good to go. That's all there is for setting up the scene, and the next thing that's left to do is the compositing. For the compositing, we're going to go ahead and press this button and choose compositor for the camera. Then we're going to just expand this quite a bit and change this from the shader editor to the compositor by pressing this button over here. Now we're going to check the use nodes button so that we get the render layers and the composite nodes. Now the first thing that I want to do is add in some amount of streaks for the brighter objects. And also I'm going to go over to the render properties and change the color management from filmic to AGX so that we get a much nicer representation of the bright colors. Then I'll press Shift A and search for maybe a glare node. Now I'm going to change this so that we get a much lesser effect. To do that, the first thing that you should note is that if you change the mix all the way to -1, you get only the image, and if you change it all the way to 1, you get only the glare that's being composited onto the image. So we're going to actually keep this mix at a very low value. Let's go with a value of -0.8 so that we have very, very little bit of a glare. The next thing is the threshold. By reducing the threshold, more and more of the areas will get the glare. By increasing it, lesser of the objects and only the brightest ones will get the glare. So I'm actually going to keep the threshold at a value of 3 so that very few of them get the glare. The next thing is that I want these to actually be a lot longer. So to make them longer, I'm just going to increase the fade from 0.9 to a value of 0.98, and that should make them a lot longer. The next thing is the number of streaks. I don't want it to be perfectly like this, so I'm just going to reduce it to 3 so that we get them at these angles just like that, which I think looks a lot better. Now remember, when you're using any type of compositing, always render it, because the render will not look the exact same as what it looks like in the viewport, because this is something that's added on top of the rendered pixels. So if you are seeing it right now, I'm probably seeing it at less than 720p, but I'm going to render it out at 4K. So the number of pixels are going to be completely different. So the actual effect is also going to be different. But for now, this is giving me a rough idea. I can render it and make changes later on. The next thing that I want is to add in some amount of glow. So to add in some glow, I'm just going to use another glare node. So let's select this, press Shift D. And this time for the glare node, I'm going to change this from streaks to fog glow. Now I can take this image, plug that in, and I want to add in this glare on top of whatever output I was getting over here. So for that, I can press Shift A, search for a mix color node, and plug that in right over here. Instead of mix, I'm going to change this to add, and I'm simply going to add in the glare to this particular image. So I'm going to increase this mix all the way to 1 so that we just get the glare from this output over here, and on top of that we're going to add in the actual streaks. So that looks great. I think the last thing that I want to do is add in another glare, but this time we're going to make it ghosts. So let's shift this over, duplicate this add node, and now duplicate this glare by pressing Shift D. Take this image and plug it into the image, and now we can plug this right over here. And instead of keeping this at streaks, we're going to change this to ghosts. Now in order to see it, I'm just going to increase the mix to a value of 1, and I'm going to reduce the threshold from 3 down to 0. Similarly, I think the threshold for the glare can also be reduced so that we get a lot more glare. So let's keep that threshold at, maybe 1.6 is good enough. Now for the ghosts, right now it does look all right, but when you render it, I'll actually show you, you get each individual image visible, or each individual ghost visible. So let's just go ahead and just render the image. So this is what it looks like, and each individual circle is clearly visible, and I don't really like that. I want this to be a lot more blurred out. So in order to blur out all of these circles so that you just get a nice type of ghost, you can just take the output of this glare node, press Shift A, and search for a blur node. Now when you plug this in, we can keep it at the default Gaussian and just change this X and Y blur to a high amount. Maybe we can blur it by something like 100, and that will give a really nice output. So of course you can play a little bit more with the compositing, such as the brightness and contrast. You can actually change the look to high contrast and things like that. It all really depends on what you want your final output to look like, but I'm going to leave it just like this for now. If you're happy with the way your render is looking, you can then go ahead and click Render Animation. I hope this tutorial was slow enough for everyone to understand. If you still have any questions, feel free to comment it down below, and I will definitely answer as many of the questions as I possibly can. If you feel like this tutorial was way too slow, let me know, and maybe I'll create a similar tutorial except at a much faster pace, so that people that enjoy faster tutorials and don't have time to go through the slower ones can actually follow along the fast tutorial as well. I know that my next video was supposed to be a music video, but that is taking longer than expected, and I think instead of the music video, I'll directly skip over to a short film, which I will upload very, very soon, but that will be my 5,000 subscriber special. So hopefully by the time I am ready to upload the short film, I will have 5,000 subscribers. So if you haven't subscribed to this channel already, please do. And for those of you that are subscribed and actually are watching all of my videos, thank you so much. You all are the reason that I am able to create these videos. Until my next video comes out, which will probably be in another week, thank you so much for watching. Keep creating and don't forget to stay creative.